Welcome to Microsoft Build 2017. This presentation is intended for developers targeting retail and hospitality solutions which require access to specialized peripherals. Universal Windows Platform provides scenario APIs for a number of these specialized peripherals, but does not support everything you may need for your solution. My name is Terry Warwick, and I'm a program manager in the Windows Peripherals team. In this video, Marcus and I will introduce you to two concepts that will help you work with additional specialized peripherals on the desktop version of Windows 10 Creators Update. First, let's take a look at peripherals APIs that are currently supported in Windows UWP. Barcode Scanner supports USB scanners configured in HID pause scanner mode, as well as Bluetooth scanners configured as simple serial interface. Receipt printer and cash drawer both support IP and Bluetooth attached devices through ESC POS simulation. Magnetic stripe reader supports USB devices from IDTech and MagTech. And finally, line display is new to the Creators Update and relies on OPOS service objects, but I'll get to that in a second. There is a gap in our support for receipt printer, cash drawer, and line display connected directly to the PC. But I should say there was a gap. In Windows 10 Creators Update for the PC, we have provided a bridge to OPOS, which is a peripheral abstraction interface that you may have used in the past for your desktop applications. With OPOS Bridge, you can access locally connected peripherals, receipt printers, cash drawers, and customer-facing line displays using our point-of-service API namespace. You simply install the appropriate OPOS components from your peripheral manufacturer according to their instructions and on Windows 10 Creators Update, and your peripherals will be accessible from your application without changing a single line of code or rebuilding your application. I would like to introduce Marcus to show us how OPOS Bridge works.
Thank you, Terry. Hi, my name is Marcus Breda. I'm a program manager in the Windows Developer Platform team. So to show this in action, first I want to describe to you the environment that we are using, because it's key, because we took the approach to doing the before and after, so you can realize how much functionality the OPOS Bridge will bring to your platform. We have here two Windows PCs. Each PC has this Epson receipt printer connected. They are using direct USB connection, which you mentioned was not previous support. The big difference in these two systems is because one of them is using the Windows Anniversary Update, and the second one is using our latest release, the Windows Creator Update, the one that has the OPOS Bridge on it. So first, if we go to the computer here, we can access and demonstrate that the printer is actually working. In order to do that, I'm going to use a sample application that comes with OPOS.NET library, and you can install it directly from the internet. If we open here this legacy application, this sample application, you can search for the printer, you can open, claim, and enable the device. A pretty standard operations that people usually do with these peripherals. If we paste a sample text here, we can print, and we'll see that the printer is actually working.
So you're using Pause4.net here, interacting with your Epson printer, correct?
That's correct. So right now, we can assure that there is no smoke mirror here. We are actually doing everything, and the printer is properly configured, right? So first, let me release and close. Let me demonstrate the problem we used to have with the anniversary update. If we open a pure UWP application, let's use, for example, the Post Printer, an application that you guys can get access directly on our GitHub repository. So it's completely open. You can check later on the code. You see that you can try to mimic the same situation, try to print with the printer, right? If we try to find the printer, we'll see that we cannot find it. And the reason is because during the anniversary update, the previous release of Windows 10, the scenario of Direct Connect was not supported. But let's see what happens if we use exactly the same environment, but just upgrading Windows to the new release. Here, it's machine, exactly the same configuration. The only difference here is we are running the creators update. If we open the exactly same application, there is not a single line of code change here, is exactly same. And we try to find and claim the printer. We'll be trying to find in the printer, and it claimed and enabled the printer. And now we can print a recipe. Print a receipt. So you see that exactly the same application without any code change now is able to handle this scenario, which is a pretty common in the point of sale space.
And the only difference between the two systems that you're using is one is running the Windows 10 anniversary update, and the one where you can successfully access this USB printer is running the Windows 10 Creators Update.
That's correct. Just because now we provide the OPAWS bridge, your application without any change has more capability and can work in larger and different environments like this one. Terry, I think you have more things to show us today,
That's fantastic, Marcus. I really appreciate the demo. So now, in a recap there, as you can see, the OPAWS bridge helps fill a gap in USB connectivity for receipt printer, cash drawer, and line displays. But what about other peripheral types, such as scales, or fiscal printers, and so forth? Before we get there, I'd like to introduce a concept, the desktop bridge. Some of you may be familiar with the desktop bridge, some of you may not. But in summary, the desktop bridge provides a migration path for Win32 applications that you can see here on the left-hand side of the screen, migrating to UWP on the right-hand side of the screen over time, simply by replacing Win32 code with UWP code, converting it all the way to UWP application. Therefore, if you have a UWP application and you need to access peripherals that are not yet supported on UWP, you can actually move the opposite direction on the desktop bridge and add a Win32 process to your UWP application. The Win32 process of this hybrid application can then access peripherals through OPAWS or PAWS4.NET, just like any Win32 application would. Marcus, can you show us how this works?
Of course. So the first thing I want to do is showing the application working, UWP using the desktop bridge technology, working with this scale, right? The scale is not inside the list of the device supported in Windows Device Point of Sale API. So it's not a native UWP API that you can call. So in order to work with a scale, you need to use the classical OPAWS. In our case, we will be using the PAWS4.NET, right? So what we did, looking here on the computer, we have adding a scenario to the sample code, and the sample code will be working directly with this scale.
So you've taken the sample code that you just used earlier.
Exactly. We just added scenario. So it has the look and feel of the UWP. It uses all the UWP functionalities and API, and we are adding a component to run the part of the code that is not native support in the UWP, which is the part that talks directly with this scale, right? Let me show this working. First, I will do something symmetric, what we usually do with the printer. We'll open, we'll claim, and we will enable the device, right? So in this case, you can see that for people that are, for you developer that is used to this object module, we see that we open, we claim, and we enable the device. So Terry, to use the scale, would you have something that we can use to, get the weight?
Absolutely.
That's nice. So let's see the application working. If we get weight, we will see it read the weight. We also have some debugging code just to show the message going between the UWP part and the legacy part. And we also add a notification that reads and shows the weight. Now let's jump to the code and see how it works, okay? Let me close this and create some open. This is the sample code we used. All of this code is available, and we're going to make it the entire sample available later on the GitHub. We added this background process in our UWP application. From this, we are accessing the code, the legacy code. The way we do, we create an app service, and we make a communication between the UWP process with the Win32 process. So now let's make it a little bit bigger, the code. Okay. This is the part where we are going to handle the communication between the two processes. This is the side of the Win32 code. We define three main messages. The first message is to open and claim and enable the device. A second message is get me the weight. And the third message is just to say I'm ending the scenario, so stop running the process. You see that this is the call we do, asking and going to the legacy or the traditional code that a developer will be using to work with this kind of device using the opos.net code.
So this is code that they're familiar with already.
Exactly.
So interacting with pos4.net.
That's exactly. If you look to this code, you see that it's very similar with probably the applications they already have, and that's the very traditional way using the opos.net library to access scale. Right? If we look on the side from the UWP, we can see that it's very, very simple. We are just sending messages to the Win32 process and saying, do that action. And we are handling the message on the Win32 side and say, I'm doing this and getting back the results, because sometimes we might have a concurrency or something that prevents to the access, so we treat that possible errors. And then we we keep a message going and flowing between one process and another when we want to have access to more weight. All of this code will be available. The developer can play and understand better the dips between one process and another one. But it's using the Windows desktop bridge and adding a component from the opos.net and then make UWP application being able to access non-standard device that is available in the Windows device point of sale API.
So in the demo that you showed us, there was a console app running. That console app doesn't have to show all the time, correct?
That's correct. So the way we did, it's very simple to change the configuration. You just go to the project and then properties. You change your output from console application to Windows application. Then it's just save, and you compile and run, deploy. And now you have the look and feel that you are looking for. So find, you see that we started the process. The scale is ready. If you read, we have the banana's weight, right? If we put some extra pressure here, the weight changes, so it adapts. So from the user perspective, you can have pure UWP UI, and then running in the background, hidden all the code that access the legacy devices.
Very nice, very nice. Looks just like a UWP application, the sample apps that we have available on GitHub.
Yep.
Thank you, Marcus. So in summary, you can use Windows Desktop Point of Service namespace together with OPAWS Bridge, as well as Desktop Bridge, to access all of the specialty peripherals required for your retail or hospitality applications. In a call to action, try the OPAWS Bridge using one of our sample apps from GitHub and install OPAWS components for your specific hardware. And 2, try the Desktop Bridge by experimenting with the sample code that Marcus just demonstrated. We've provided that sample code at aka.ms pointofservice.build2017.samplecode. Additional resources for you in working with Point of Service. You can access our documentation, our API reference, and provide feedback on user voice. You can also learn more about Desktop Bridge at Desktop Bridge portal, and also provide feedback through user voice. Thank you for your time. Hope you enjoy Build 2017.
Thank you.